Do you remember? Oh, this doesn't look good. This doesn't look good.
Yeah, well,
Here's what. You might remember from about a week and a half ago, there was a package that I sent to you with the little ant on the side. Little parachutist there. You might remember that, and you might remember me saying that questions 7, 8, and 9, where there's a note that says must do questions 7, 8, 9. You might remember me saying that you need to do that. So I'm going to take a few minutes to go through those in hopes that you've tried them. And if not, well, that's okay. Because I will tell you this, these kind of questions are on the test.
Wait, are you talking about the that we shouldn't be able to do?
Yeah. Once again, I'm talking about this handout right here, the one that has the little ant in the corner and the parachute. May 11th. I'm going to go by hand date. And I said that question 7, 8, 9, you should do. Now those of you that got your book all organized nice should have no trouble finding it. Those of you that talk to me later. Those of you that maybe subscribe so that just jam it in there and I'll find it when I need it might have a more difficult time. I have no sympathy for you. Here's a tip for those of you that might be thinking about post-secondary. You might want to get better at organizing stuff like that. They're going to go a whole lot faster. They're not going to have this time to do what you're doing right now. They're just going to say, let's go back to this, and then they're going to start. Okay? Here's another tip. When you go to post-secondary, you don't need to take your whole binder with you. Very few students at that level do that. They'll take a little clipboard, put some stuff in it, and then when they get back to their home or their residence or wherever they are, then they put it in the binder and keep it organized that way. It is. Yeah, you don't need to carry everything around. Okay. And those of you that are still subscribing to the one binder for everything in your day, you might want to rethink that as well. Okay. Well, whatever. Anyways, let's talk about my friend Kyle. He's flying a helicopter, and for some reason he has a bag with him. Maybe it's got cash in it. I don't know. Maybe he's a generous fellow, and he's dropping a bag of cash out of the helicopter. There's an old TV show called WKRP. It's about a radio station in Cincinnati, and you might have heard it. Your parents probably watched it. There's a classic scene where on Thanksgiving, the news guy, whose name is Les, decides that for Thanksgiving he's going to drop turkeys out of the helicopter because he thought turkeys could fly. I think I should change this question for just so my own comedy value. Les is flying a helicopter when he drops a turkey in. TV show, Ty. Fictional show, wasn't a documentary. Is it? Mm-hmm. Anyways, those people listening in at home are probably wondering why we're talking about this. So let's go right. I think I've given you 4 minutes to find this question. More than enough time. So Kyle is flying a helicopter when he drops a bag. When the bag is falling 2 seconds, what is the bag's velocity? So this flying a helicopter is kind of code for the initial velocity is 0. Doesn't come right out and say that. It sort of implies it. When the bag is fallen 2 seconds, what is the bag's velocity and how far has the bag fallen? So, what do we know? We also know that the acceleration is minus 9.8. And we're looking for the bag's velocity after 2 seconds, which means the VF. So I have VI and VF in the formula, and I have A, and I also have time. So I'm hoping you're seeing the path to take here. A equals delta V over delta t. The acceleration is minus 9.8. The change in velocity is what we're going to solve for, and the time is 2. And the delta V is minus 19.6 meters per second. The velocity changes by minus 19.6 meters per second because of gravity is accelerating at minus 9.8 meters per second squared. And now, if the VI is 0, and you can write this out if you want, or you can just say it, minus 19.6 is equal to VF minus 0. In other words, yeah, the final velocity is minus 19.6 meters per second. It's going about 20 meters per second after 2 seconds. It doesn't take long to speed up, does it? That part you should have been able to do already, for sure. For sure, for sure, for sure. I'm going to take by the fact that I'm looking out here and I'm seeing over half of the class writing it down. That's sort of telling me you guys didn't try this. I'm making mental notes, by the way. How far has the bag fallen? It's not a yes or no question, Jeff.
Yes.
How far? We are solving for the displacement. Yeah. I'm going to write it over here, V bar equals d over t. And why did I write it over there? Because I know that I don't have V bar. I only got VF and I got VI. And so what do I have to do? I have to find it. By the way, those of you that are thinking about taking grade 12, I'm going to show you a way to combine those two together so that you don't have to do it in 2 steps.
Really?
Yes. Those of you that don't like country music and don't like the 2-step, we'll do it in 1 step. Those of you that like country music, well, that's okay too. So we're going to solve for V bar. 0 plus minus 19.6 all over 2. I'm still going to remind a few people, because there's still people that don't like doing it, showing your work, lining up the equal signs, writing the formula, keeping it all lined up, you know, all that good stuff. Because you're going to need it. What do you know? I just multiplied by 2 and then divided by 2. Yeah, it's one of those. So the average velocity is about 10 meters per second minus 9.8 meters per second. And then guess what I'm going to do again here, Brett? I'm going to multiply by 2. But notice that the units are changing, right? Minus 19.6 meters. Why is it negative? Because it's going down. Kyle's flying the same helicopter. It's right there. This time the helicopter is not hovering, it's rising. Okay? After 2 seconds, what is the bag's velocity? Now, would the velocity not be the same?
The initial.
Cancel it out. This after you pick up the bag drop.
Another instance, right. So what you're telling me is, I'm going to go and make my nice picture of a bag of cash. What you're telling me is that the bag and the helicopter together are doing this. They're both rising. And so now, what's the initial velocity of the bag? Plus 5. So this part is the same, but this part is same steps, just different numbers. Okay? A equals delta V over delta t minus, now I'll just do this quick because it's pretty straightforward. The change in the velocity is the same number, right? The change in the velocity is the same number, but because the bag is initially rising, and I'm just going to get rid of the helicopter for a second. The bag, so what is the bag, like if you were on the ground, what would you actually see? You would see the bag do what? If you set 0, he releases it, what would you see the bag do? Just fall straight down? would you not see it go like that? Why not? No. The initial velocity of the bag is +5. The helicopter's rising. The bag, do you not see the bag inside the helicopter rising? He lets go. The instant he lets go, the bag's initial velocity is up, +5. The bag goes up and then comes down.
But it moves sideways.
Okay?
It was going fast.
It's just not that drastic.
Well, no, it's not going to be like that, right? But I'm exaggerating so you can see it. It would literally go up and then come down. And the helicopter would continue to go down. Now, how far would the bag fall? Well, that's what we're going to find out. So, first of all, what is the bag's velocity? So now my VI is +5, so I'm going to go delta V is VF minus VI. And here's where putting your formulas in really helps. Those of you that are still fighting me on that. Minus 19.6. Solve for the VF. Minus VI. Be careful here. Subtract +5. Right? And when you subtract +5, it's really just what? Right? That's all it is. Now when that -5 goes to the other side, I get +5. It's going to be 5 minus 19.6. And now the bag is going 14.6. It's not going as fast. How come? Because it spent the first little bit of time doing what? Going up and actually slowing down. Okay? Do you see why I told you should try them? How far has the bag fallen from this 0 point, the moment that he lets go? Same steps. What did we do before? V bar equals VI plus VF over 2. What's the initial velocity? +5. What's the final velocity of this interval? Minus 14.6. So like plus minus 14.6 divided by 2. What is the average velocity of the bag? 5 minus 14.6 is? And then divide by 2.
Minus 11.2. No. Huh?
Am I right? Kai, am I right? Minus 4.9?
I got 4.8, but
Oh, yeah. Yeah. No, 4.8. 14.6. Right? Now we have to find the displacement. V bar is minus 4.8. D, 2 seconds. We're going to multiply by 2 now, and we end up back at minus 9.6 meters. The second time the bag only fell, this distance here is only 9.6 meters. Because it spent, how far did it go up? I guess we don't know. It went up and then it come down. So it ended up a displacement of minus 9.6. The first time it fell, 19.6. It's much, much farther, isn't it?
so does that mean it went up and down for 10 meters?
How far below the helicopter is the bag? Because remember, in this 2 seconds, what does the helicopter continue to do? For how long? How far up does the helicopter go? V bar equals d over t. How fast is the helicopter rising? 5. How long? 2 seconds. The helicopter goes up 10 meters. That's part C. The helicopter rises 10 meters. Goes up 10. So what if that's 10 meters and that's 9.6? The question is, how far below the helicopter is the bag? 10 plus 9.6, and what do you know? It's the same. Is that surprising, AJ? It shouldn't be. Why did I put 5? Because the velocity of the helicopter is 5. It shouldn't be. The bag is the same distance apart, whether it is just dropped or it's moving and then dropped. It's still the same displacement. Now, what if, I'm going to pause for a second because I realize you're still processing this. What if in question number 9, instead of the helicopter going up, Kyle's helicopter is now descending at 5 meters per second as he releases the bag? Why don't you try that question? I've given you the steps. It's identical. There's only one thing different. Same guy, same helicopter, same big giant bag of cash. The VI is -5. See what happens. Right? Does anything change here? The change in velocity is still minus 90.6. The only real change is this plus 5 becomes -5, which means that's going to become, that's going to become a positive 5. So when it goes over here, it becomes negative. So now instead of minus 14.6, it's actually 24.6.
What about the 9.8?
Right? 24.6? Where's the... Well, this is remember, this is subtract -5, which makes the right-hand side plus 5. So when it goes to the left, it becomes negative. It's going faster negatively, which makes sense, right? Because now the bag and the helicopter are both doing this, right? So its initial velocity, so it's in fact, the bag is going to be going really fast, right? So that's 24.6. So now over here, this VF is, so now that's going to be plus negative 24.6. Oh yeah, right. So now that's where that 29 comes from, right, Brad? But then divide by 2, so that's going to be 14.8 minus 14.8. Yeah, and so that's negative 14.8, and times by 2 is? The bag falls or drops 29.6 meters down, but the helicopter is going down. How far down does it go? -5, -10. So now it's not these numbers here, it's really what? Right? The bag falls down 29.6, but the helicopter drops down 10 as well, and what do you get?
Whoa.
The same number. And why is that? It's because of what is common to the answers in problem 7, 8, 9? The distance between the bag and the helicopter, and why? Because of gravity. Because the acceleration, because the acceleration for all three of them is minus 9.8.
What would you do if, like, the helicopter was not moving at a constant speed?
Oh, okay, then you're getting a little more complicated. Yeah.
We're not going to do that.
No. Here's another question, seeing as you're coming up with questions. What if the helicopter wasn't going up or down? What if the helicopter was going sideways? What would the bag do? Would the bag drop straight down? What would the bag do? It would do this. And that's known as projectile motion, which is covered in grade 12. It's really just the same thing. It's just that instead of the x component of the bag being 0, the x component of the bag is whatever it is given, right? That's all it is. It all fits together. Physics is all just adding on little pieces, just kind of, it's like building that cabin, you keep adding on. Lego, yeah. Yeah, building that fort when you're a kid, let's put this on here, that kind of thing. Remember yesterday I showed you these. Example number 1, this was coefficient of friction stuff, horizontal force. So here it's moving at a constant velocity. That is when the applied force is equal to the friction force, right? Not accelerating. Example number 2, here, what is the overall acceleration box? That's happening because the FA is greater than the FF, right? And remember from yesterday, mu equals FF over FM. Okay, well, I'm going to take all of that knowledge one more step. And now, in this one here, the box has a mass of 46 kilograms, pulled along the level 4 at a constant speed, meaning that the forces are
Equal.
balanced, equal, but this time the rope is at an angle of 30 degrees. So it's not a horizontal force, it's a force at a bit of an angle, adding one more layer of degree of difficulty. Do you know where it is, Jeff? You'd be surprised at how much easier it becomes when you can find out what I'm talking about. Okay, so box has a mass of 46 kilograms, pulled along level 4 at constant speed. The rope makes an angle of 30 degrees, that the force in the rope is 260. What is the horizontal component? Now, does yours say FH? Does yours say FH?
Yeah.
Let's change that to the new terminology, FAX. Right? X component of the applied force. Okay, so step 1, what is FAX? Now, you might remember from before that the X component of that little triangle there, this is FAX, that is adjacent to, so it's going to be cosine. FAX is equal to FA cos theta. (260) cos 30. Brett, you do the math for me because you know. Do you want to write any of this down? No.
That's 130 times square root of 3 is something. Oh, okay. 130 times square root of,
225.166.
there you go. Thanks.
No problem.
225.166?
Yeah.
We'll say 0.2.
Okay.
So of that 260 newtons, 225.2 is doing what? Pulling it sideways. Now, if I just knew friction, like let's say the friction force was 10, minus 10, then the FAX would be 215, right? You just subtract it. But we don't. We don't know what the friction force is. It's asking what is the coefficient of sliding friction. What is the mu value? Mu equals FF over Fn. We have to find Fn. Now, brand new idea for you here. Up to now, the weight force and the normal force have been equal. Why are they not equal here?
Oh, because it's pulling up on an angle.
That is right. They're equal. They're always used to be equal because those are the only forces. One down, one up. If they add up to 0, they have to be equal to each other, right? But now I have, not FAX, now I have FAY. I have a Y component of the force. As I'm pulling at an angle, I'm not only pulling sideways, but I'm pulling up. And you should know, like if you're trying to push something heavy, what's one way to reduce friction? If you lift it a bit, right? Reduces the friction. Okay, so that's in fact what you're doing here. So I need to find FAY. Now, if FAX is FA cos theta, adjacent, FAY is going to be FA sine theta.
no way. Mr. Bad.
Are you thankful that you have a cheat sheet and it's not 15 years ago when I made everybody memorize this stuff?
Yes.
Every 130.
Yep.
We don't have to keep it.
They did it. 130 newtons.
We need to remember this.
You need to know how to do it. 130 newtons. That is in the upward direction, positive. Okay, now, here's how I'm now teaching this. It's a little bit different than what you'll see in the solutions. I'm going to say F net Y. The Y, the total of all the Y forces up and down is
Equal to that.
0. Right? The Y, the total F net up and down is 0. Why? Because it's not accelerating up and it's not accelerating down. 0. And what makes up that F net Y?
The weight, the normal, and...
Bingo.
the-
The weight force, which is down. The normal force, right? This one and this one and this one. Fw plus Fn plus Fay equals 0.
Why is there two
Well,
equal
it's
signs?
class, so he does.
Wouldn't that be the scam of the century if I was just making this stuff up?
Goes on to do physics.
Now, Mr. Bennett retires, someone else comes in, starts looking at stuff. What was he teaching them? None of this is true.
Actually, fake news.
Yes, total fake news, fake curriculum for 20-some years.
No one knows.
You could be making
up.
I mean, that is true, you could be making it up.
Or we could just...
You are putting a lot of trust in me, aren't you, Cole?
We could just like open a book or do some research.
Maybe I've made all those books myself. Yeah, and aged them appropriately so they look old like that, right? I've also sanitized the internet so that none of this you'll find on the internet.
Oh, yes.
Yeah, right.
Yeah.
Yeah. Good one. It's all a big conspiracy theory. You know, I was one of those guys that wasn't on the moon.
All the school.
Yes, it could be. That could be true.
What if 1 plus 1 was actually 3? Plot twist, eh?
Well, if it was a vector. All right. So F net Y. So what is the weight force? Now, how do I find weight force? It's equal to mass times gravity. You'll notice that it's right here. Okay, so do you have that little diagram? You have to draw, right? Okay, so I want you to put in here somewhere Fw is equal to 46 times minus 9.8, and that's going to be equal to minus 450.8. Okay, the mass, 46. Stay with me here, you guys. I got about 3 more minutes. You're starting to, I see your attention span waning a bit. 46 is the mass, minus 9.8. So the weight force is minus 450.8. So, I know, you should have drawn it. Yeah. How is it too late now? You have to draw it. You can draw it still somewhere. Okay, so anyways, I've got weight force minus 450.8 negative plus Fn, and slow me down if I'm going too fast. Okay. The sum of all the y forces is equal to 0, and that F net y is made up of, maybe, do you want me to put it like this? Would this make it more visual sense? Would you like me to do this? Does that look better? Well, F net y is made up of these 3. So we're solving for Fn. Do we know Fay?
Yeah.
We do. It's this number right here. Now, which direction is it, Sarah? Jeff, you should be watching.
Oh,
This way. The screen's over here. Fay is 130, and it is up. So that's going to be plus 130 is all equal to 0. So Fw minus 450.8 is down. It's negative. Plus the Fn plus the 130 is equal to 0. So what is Fn equal to? Minus 450.8 goes to the other side, becomes plus 450.8. And the 130 goes to the other side and becomes minus 130. And if you stop and you think about it, It makes sense. The table, well, if you stop and think about it, if the weight force is 450.8, right? If gravity's pulling down with 450.8, the table has to push up with 450.8. But if Ty is pulling on the rope and helping the table out by lifting with 130 newtons, the table has to do less work. How much does the table have to do? 120.8. If you add the table and Ty's component, and that number is not right, is it? That's not even close to right. 320, yeah.
All right, there we go.
There we go. That's better. Actually, if you were confused by that, that tells me that you paying attention and actually got it. If you were just blindly going along and you're not paying attention. 320.8. So in other words, that's a 450 there, right? In other words, the table only has to push up with 320. How come? Because Ty's doing 130 newtons over the work. Or whoever. Okay. Part C, and then we're done. Part C says, what is the coefficient of friction? Actually, I won't say that we're entirely done because I got to add one more thing at the end. Mu equals FF over Fn. So, what is the friction force here? Oh, we haven't even talked about friction force here, Jeff. What is, let's go back, let's think. Box with a mass of 46 kilograms is pulled along at a level 4 at a constant speed. Oh, now I remember. Constant speed, that means that the x components add up to 0. They're equal. So that means that FAX and FF are the same.
Wow.
Right? Maybe I'll put that over there, and I'm going to say over here, part C, I'm going to say that FF is equal to 225.2. Technically, it's negative because it's to the left. Why? Moving at a constant speed. Here's my Fn. And so my mu value is 225.2. Remember that the negatives don't matter in the mu calculation because it's just a number, it's just a ratio. And I don't know what that is. Brett, help us out here. 225.2 divided by 320.8. 0.7?
So what is that actually like?
It's just a number that tells you how much friction there is between, it's a measure of how rough the surfaces are together. The bigger the number, the more friction. Okay? Teflon and ice would have a very low number. Did I tell you yesterday that the mu values are almost always below 1? Mu values are almost always below 1.
Really? What's one?
You're lying.
No, I'm not.
Extremely free.
It's, one is like, yeah, like rubber on gravel road kind of thing. Well, I guess that's not true because you roll, right? Yeah. Rubber on sandpaper. Lots of friction. The bigger the number, the more the friction. The rougher.
You do, like, if it's wheels, you said it's different, right?
If it's rolling, it's different. These are all assuming sliding.
So that's like, yeah, so you can't do like tires. Or
You can, it's just a little bit more complicated. That's down the road.
No, it's different.
Yeah. Go be an engineer. Okay. Now, one last comment, and then I'm going to stop. I promise. The mu value doesn't change. Okay, this is important. Refocus here. The mu value, Johnny, get off that phone, Brazilians, and listen. Usually at the end of the lecture is the sum up, the important part. Junior, are you listening?
Yeah.
I meant Leo. I see you were listening. I meant Leo.
Yeah.
Okay, the mu value doesn't change. How rough, if I'm rubbing my, where's my hole punch? If I'm pushing the hole punch across the table, this is a certain degree of stickiness, roughness that goes to the table. That mu value doesn't change. If I put something heavy on it, like this, have I changed the roughness of the surfaces.
No.
Okay.
I have it. What have I changed? I've changed the weight force. I've changed the mass. Okay. Go back to the formula. If the mu value can't change, right? So if my 0.7 has to be the same, 0.7 is equal to FF over Fn. If I make my Fn bigger by doing what? By adding weight, to make the equation balance, I have to make my FF bigger. And what does that do? It adds more friction. So the frictional coefficient doesn't change, the normal force changes, and thus, because of sort of this thing, the friction force changes. When you add mass, you increase friction. You don't increase frictional coefficient.
What is the number for mu?
In this case, it was 0.7. Every two surfaces have different numbers. It's not a constant. It's not constant. If it's like wood on wood, and you're going to do this in grade 12, if it's wood sliding on wood, it's about 0.25. If it's rubber on the road, it's about 0.4. Yeah, that would, sandpaper against sandpaper would be like 0.9. Right? It depends on what the two things are. If it's a wet road, it's a different frictional coefficient. When the accident reconstructionist guy comes out, and he does the lab that I've done with classes before, he actually gets a big block with a hunk of tire, and he pulls it across the road, and he measures how much force, and then he does calculations and figures out what the frictional coefficient is that day right there on that piece of road. And then he can figure out, this is math backwards, how fast the car's going. Yeah, it's not that hard. Yeah. I've had him come out and do it on the Kerr average, right?
Yeah.
I didn't set it up this year. Here's a whole bunch of questions. You should do some. Reminder, no school Monday. Test is either Thursday or Friday. Next week.
Just on all the gravity stuff?
Yeah. Just on gravity stuff. I got one more. I don't really have anything new to teach. I have a friction sort of review that we can go through on Tuesday. Test is either Thursday or Friday. We'll make that decision Tuesday. Okay? Thank you for your attention today.